Okay, so this is Agustín Ibáñez. I am the director of the Global Brain Networks at the Global Brain Health Institute in the Trinity College Dublin. I am also the scientific director of the Latin American Brain Health Institute and the founder and co-director of the ReDLat consortium. My research is mainly focusing developing global brain health with a synergic approach, I would say, like combining um, different aspects of the environment that we call it exposome, from pollution to socioeconomic inequality, with also whole body health involving cardiometabolic, inflammatory, metabolic pathways, as well as brain health in aging and dementia mainly, and developing uh, innovative computational models to deal with this multi-level data integration and with the kind of heterogeneity. My work is really focusing global data and trying to bring more tailored and personalized brain health. For example, when you think about risk factors, those are not distributed equally. Different factors are important in different regions, or when you think in genetic influences, they are really heavily influenced by admixtures and different genetic environmental interactions. So the overall idea is to develop very local based models for improve the precision. Yeah, so I think that my approach to global science comes from scarcity. I was working in San Juan and Argentina, a very deprived region and country regarding funding, international collaborations and opportunities. So I was always struggling to get publications, to get trained people, to make the right question for my local settings to be relevant in global settings. So this scarcity really pushes me to look for other alternatives, and I found that this problem is shared across Latin America and then in Africa, then in Asia. So it was a huge opportunity to transform these big challenges in opportunities. Like, if you connect the dots, if the people work together, the first thing that you have is that you multiply your data. That this is a very, very important first step, because you are able to, answer better questions with larger samples. And then the other thing is when you start to work together to harmonize protocols, to create, um, shared approaches across regions and respecting also the local heterogeneity from clinical assessment to genetic data, just as an example. This brings you a more robust science, and you can get funding. So I was working with that. Still, there are many challenges, they are different regions. If you look, for example, Africa is facing really, more strong capacity building limitation if you compare with Latin America in general. South Asia also have some countries that really needs to improve the international collaboration. The other challenge is that most of the research that I have been able to find in global settings come from global stakeholders without much local support. And this is a weakness, because without having local support, all become dependent on grants. And when you don't get a grant, or when the grant is finished, you are at risk to lose all the training people, all the advances that you have been made. So it's a very unstable equilibrium, I would say. But still, I think that governments in global south settings are more limited for provide funding for one side. And for other side, I think that the solution is not necessarily purely public. I think that private companies and global stakeholders have to develop a more intrinsic collaboration, more radical collaboration, I would say, with centers in the global south. I think that we are facing a unique opportunity in the history of science, because the amount of data that is available in digital settings combined with AI, generative AI, is really transforming the field. We don't know how quick it's going to be transformative. We have, like, for instance, Delphi 2PM is a foundational model trained with 2 million of people that can do 1,000 diagnoses with high accuracy and predict, the future trajectories for 20 years. Imagine the impact that this can have in a, in the the primary care setting in in the hospital or in a nation. So it's huge. It's huge. But at the same time, they are very high risk. One risk is, the lack of control that we are going to have from this generative AI. It's very well known that if you use a little, very small of poison information, like fake information within the algorithms, they can become very biased, very easy, and produce errors relatively easy. So this is one problem. The other problem is the complexity of the analysis. At some point will be out of control for humans, right? So this is the other problem or challenge. Of course, the other problem will be this skilling and lack of motivation of people if they lose control. So I think that bringing computers and human is essential for digital assessment. There are so many unique opportunities. The most obvious things, are this kind of using clinical available data to predict real world impact. That is something that science has been always struggling with the traditional approaches. And I think that the other very exciting development is digital twins in general. Being able to create synthetic data based on empirical data and modeling the impact of interventions or treatments in a personalized way. We are now starting to develop in individual biophysical brain twins for modeling interventions and disease using empirical and simulated data at individual level. I think that is very exciting.